Alright guys, so today we will be talking about Chapter 8, Confidence Intervals. Intervals. Alright. And so when we're talking about... Where'd my beard go? Where's my beard? We're going to begin by finding a confidence interval for a population proportion. So we're going to start off with our sample. We got 200 households, okay? And of these 200 households, only 152 of them have just one computer. Okay? And to find our sample proportion, we'll do that 152 of the households that have a computer, and we'll put that over our total number of households, which is 200. And that number used to be 0.76. Here, let me check my calculator, see if that's right. Okay, 152 over 200, 0.76. Yeah, that's correct. Okay. Okay, so we have 0.76 as our sample proportion. And now we must check our conditions. So for the sake of the example, we're going to assume it's random. It's a random sample. And for our 10% rule, we're going to say the 200 households is less than 10% of all the households in the area. And then for our large counts, we have n times p times q. So we have our 200 times 0.76 times 1 minus 0.76, which comes out to be 36.48. And this, of course, is greater than 10. So all the conditions are met. Once we have checked that our conditions are met, we can get right into the problem. We have our formula, p hat plus or minus our z, which we'll find in just a minute, times the square root of our sample proportion times q hat, over the population n. So we're finding a 95% confidence interval, and we know that 95% is within 2 standard deviations of the mean. And so on these tail ends outside of the 2 standard deviations, we have a total of 5%. So on each side we have 2.5%. So if we have 0.025, we have 2.5% on each side of the 2 standard deviations. So to find our z for this formula, we'll go to our z table in the back of the book, and we'll find that our z score is 1.96. Our z score is 1.96. Now all we have to do is plug everything into the problem. So we plug it all into our formula. We have our 0.76 minus our z, 1.96, times our 0.76 times our 1 minus 0.76 all over 200, and that computes to be 0.701, and it's plus or minus, so we have to do it the same but adding our 196 divided by blah 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 over 200, and that comes out to be 8.819. So we have both our lower bound and our upper bound, and our interval would be between these two, and it would be written as 0.701, 0.819. With our interval being this 0.701, 0.819, we can now conclude and say that we are 95% sure, or we're 95% confident that the interval .701, comma .18819 will capture the true proportion of households that have one computer, and that is for the entire population. That will find that is estimating the population proportion. We are now going to move into using confidence intervals to find the population mean using from a sample. So we're going to start off with our example. We have verbal section. On a verbal section of SAT, a sample of 25 students. So we have a sample of 25 students. 25 students, and their mean score was 480. So their mean score for the sample was 480, and this has a standard deviation. The sample has a standard deviation of 85. For this example, we're going to assume all conditions are met, and so we're going to go with our formula of x bar plus or minus our t-value, which we'll find in just a moment, and that is multiplied by our sample standard deviation, because we don't know our population standard deviation, over the square root of our population n. Again, we are finding a 95% confidence interval, so we have our 2 standard deviations away. We have our 2.5% on each side, because we have 5 total. And so now we got to find our t-value. So we got to find our degrees of freedom. So we have a total of 25 students, so 25 minus 1 equals 24. And 24 is our degrees of freedom. And so we'll take that to our t-table, which is in the back of the book. We'll take that to our t-table, and we'll find that our t-value is equal to, what is it? Where is it at here? 2.0632. So our t-value is 2.0632. Now that we have our t-value, we can begin plugging things in. So we have our x, we have our 480, which is our mean score for them, plus or minus our t-value, 2.0632, times our sample standard deviation, which is 85, duh, and the square root of n being 25, our sample. And plus and minus, we get our lower bound to be, our lower bound would be 444.9256, and our upper bound would be 515.0744. And from here, we can conclude that we are 95% confident that the interval 444.9256 and 515.0744 will capture the true mean of the verbal section of the SAT scores for all of the students in the population.